Greetings, my little triglets. How are you today? Hope you are doing well. Today we are going to do section 4.5. We are going to talk about the inverse of the functions that we've been drawing. Now, just a little quick reminder, function, don't forget the first three letters, may or may not have an inverse. Now, inverses are important because for example, let's say you have a formula that has distance and you want to get it in terms of time. Well, what if you want to do the inverse? What if you have the time and you want to get it in terms of the distance? So these have inverses, and it depends on what information you're given, whether you can, use one or the other. Now, do you remember in Algebra 2 you had a test that would say if something was was a function or not. A function is 1 to 1 also, meaning for every x there's only one y, and for every y there's only one x. So we had something called the vertical line test. Now the vertical line test, basically, if you can draw a vertical line through the function and it only hits it once, then it is a function. Now if I take the inverse of this function right here, which would look about like this, the vertical line test now does not work. It fails. And so this is not a function. This is, yes, it is a function. This is not, because I have two y values for the same x. Here's the x value and the two y values, one above and one below. So it's not a function. Scientists like things to be functions because then we only get one answer. And you know from things we've done before, like sine of theta equals 0.5, well, theta could be 30 degrees or it could be 150 degrees. There's two answers. Well, to avoid confusion, what we're going to do is we're going to restrict the quadrants in which you can choose your answers. So let's look at sine. If I do sine of theta is 0.5, your answer can be either here or here. If I restrict it and say that the sine value can only be between negative pi over 2 and pi over 2, I'm going to restrict the domain. Here's my domain. That means the x values. So pi over 2 is up here. Negative pi over 2 is here. So I can only go between here and here. So now you know exactly which answer you want. You want the one that's between there, so it would be 30. Now how do you know when it's restricted or not? Well, they use a capital S for that. So you might see capital S with an inverse representing that you only want one answer. So if I say capital S inverse of 0.5, your answer is just going to be 30 or pi over 6. If I do capital S inverse of 0, meaning where is sine 0? Think about your circle. Sine is 0 when you don't go up or down, so that would be at 0 degrees or 0 radians. We're at capital S sine of 2.258. Well, we don't know that one on our circle, so you've got to go to your calculator. So you do the inverse sine of that, you hit it, and you get about 15 degrees. In radians, it's about 0.261. And make sure that that answer is in either the first or the fourth quadrant. And if it's in the fourth quadrant, it's got to be negative. Okay, it's not going all the way around. If you say it's in the fourth quadrant going all the way around, that's the wrong answer. You can only go from 0 negative and from 0 positive. I call this the dead zone. If you go through here for the sine function, you may not even cross through there. You may not walk through here. It's like a minefield, and you will die if you get through this quadrant. Even if you get through that quadrant to make it into the fourth, you won't survive. So don't even try to go there. You need to just go positive to the first quadrant or negative to get in that fourth quadrant. Try this one on your calculator. Capital sine inverse of 1.5. Do it on your calculator right now. I'll wait. I'm still waiting. Okay. You should get error. And the reason is because remember, sine and cosine can't go beyond 1. Okay? Their range can't go beyond 1 or negative 1. Now in the book, sometimes there's an old-fashioned way to write this, and it's called arc sine. These two things mean the exact same thing. Arc sine is the same as capital S, and they do use capital A as well. So those mean the exact same thing. So let's do a couple more examples here. Let's say I have the arc sine of 0.3240, and I want you to get the answer in radians. So you just do the inverse sine of 0.3240. On your calculator in radians, you should get about 0.33. If you did it in degrees, it's about 18.9 degrees. All right, so a quick recap is for arc sine, your answers can only be in this area. This is positive, this is negative. You may not go through the dead zone. These are bad places. Now cosine, capital C cosine is restricted in a different area. Cosine, you get a positive answer here and a negative answer here. So you're restricted from 0 to pi because you'll get all your positives and negatives in those two quadrants. These are the dead zones for cosine. Don't go in there. Stay away. It's bad. It's dangerous. So the arc cosine of pi over, or let's say 0, arc cosine of 0 when you're not going left or right. So that would mean pi over 2. What's the arc cosine of 0.5? Well, where do you get cosine positive? Right here. 0.5 is halfway. That's pi over 3. And then also arc cosine is the same thing. That's inverse cosine. Arc cosine of 1. Where is cosine equal to 1? If I look on this circle, if I go 1 over cosine, it's 0 degrees or 0 radians, however you want to answer that. So don't go outside the boundaries. Now, a couple more things. If, let's say I had this, the cosine of the arc sine of 3/5. Okay, now 3/5 isn't on our circle either, but we want to know the cosine of it. I don't really need the angle. So what I'm going to do is I'm going to draw a triangle. Positive sine in its restricted zone, here's the restricted zone, is in the first quadrant. Sine is y over r. So if I just draw a random triangle in the first quadrant, y is 3, r is 5. If I want to know cosine, I have to know x over r. Well, I know r is 5, I just need to find the x. And hopefully you all figured it out by now. X is 3, 4, 5. So the cosine of the arc sine of 3/5 is 4/5. It's saying, what's the cosine of this angle? This represents an angle, theta. So if you have a problem like that, just draw the triangle and you don't even need to know the angle. Not at all. All right, I have one little formula that you need to memorize. And it deals with optics. There's a formula. Let's see, I'm going to use blue because we have to talk about water. If we have water and we have a vertical line going through there and you know when you clean the pool and you put that big long um, sweeper thing in there? That's to scoop the bottom of the pool, and it looks like it bends. The water makes it look like it bends. It doesn't technically bend, but the water distorts it so it looks like it bends. We're going to call this angle I. The I stands for the angle of incidence. And we're going to call this angle down here R because it's the angle of refraction. Okay. The formula that you have to know that someone figured out by measuring these angles over and over and over again, they found out that the sine of the angle of incidence over the sine of the angle of refraction is always in the ratio of 4 to 3. It's not that the angles are, but their sine values are always in the ratio of 4 to 3. So let's say that I know that the angle of inference is 30 degrees. I want you to find the angle of refraction, find R. So just plug it in. Sine of 30 over the sine of R equals 4/3. Sine of 30 is really 0.5. And now it's just a cross multiply deal. So I have these two, 0.5 times 3, and then I'm going to end up dividing by 4 equals the sine of R. If I do all that, I get 0.375 equals sine of R. But I don't want the sine of R, I want to know what R is. It says just to find R here. So how do we do that? If we're given the sine of R, let's go over here. I need to take the inverse sine of R. I'm sorry, of 0.375. Let me get rid of that. And that will equal R. So inverse sine of 0.375 is approximately 22 degrees. Okay, so just memorize this little formula. Um, this represents the angle in the air. This represents the angle in the water. So if you can remember that, that will help. All right, so that's where you would use an inverse sine. It wouldn't have to be the arc sine, but that's where it's used. All right, well, you know the drill. Trig loves you, don't forget. Ta-ta for now.